Hi 143 class, this is your homework examples from section 2B. So this is problem number 8 in 2B. And what we're being told here is gas mileage varies slightly when we change the speed of the car. Okay. Suppose your car averages 38 miles per gallon on the highway if your speed is 53 miles per hour, and it averages 21 miles per gallon on the highway if your speed is 66 miles per hour. Okay, so going faster changes the miles per gallon here pretty significantly. All right, what's the driving time for a 2,900 mile trip if you drive an average speed of this? And then what's the driving time when you do an average speed of this? Now remember, what we're dealing with here in this first question is distance equals rate times time. Okay, so what's the driving time? Time equals, we can solve for time by dividing both sides by rate. So I divide by rate on the left and right, and we get time equals distance divided by rate. So what's the driving time for a 2,900 mile trip if you drive an average speed of 53 miles per hour? So I'm going to take 2,900, I'm going to divide by 53. Alright, I get 54.72. That's hours. Alright, and then if we have an average speed of 66 miles per hour, so 2,900 divided by 66 equals 43.94. And again, that's going to be hours. Okay, so we saved ourselves about 11 hours of drive time. Alright, part B. If the price of gasoline is this amount, we want to know what's the cost of averaging that 53 miles an hour versus 66 miles an hour. So how much do we pay to save 11 hours of drive time? So if you see right here what we did, we took miles and divided by miles per hour, and we ended up with hours. So miles divided by miles per hour equals hours. Okay, miles divided by miles per hour equals this unit. So what we're trying to use here is the same concept. If I take miles and divide by miles per gallon, just like here miles divided by miles per hour is hours, here I'll get gallons. So if I take the 2,900 miles that I've got to drive and I divide by the miles per gallon for driving that speed, this would be how many gallons I used. And then if I have to spend $4.75 per gallon, I'll find out how much money I spend to drive at 53 miles per hour versus 66. So let's see what the cost is. All right, 2,900 divided by 38 is 76.3. That's how many gallons I'll need to travel this distance. And then if I spend $4.75 for each mile, that's $362.50 is how much it's going to cost if I average 53 miles per hour. Right now, if I average 66 miles per hour, my miles per gallon falls all the way down to 21 miles per gallon. That setup is going to look like this. If I basically repeat the process, 2,900 divided by, instead of 38, I'm dividing by 21, and then multiplying by 4.75. There's $655.95. Alright, and again, that's if I'm going 66 miles per hour. So this is what people think about when they go fast, is I'm saving a lot of time. But this is not what people think about, is that I'm maybe spend more money. Now this is a drastic difference, okay? It's probably not going to be that much necessarily difference, but there is a money cost that you got to consider when you do go faster in an automobile, okay? So anyway, this was in there first because it's just to remind you, a lot of people know this concept that if I take the distance divided by the rate, that's how long it's going to take. But I'm just trying to get you to see that if you use that same logic, miles divided by miles per hour equals hours, you can get the number of gallons that same way. All right, this is number 9 in your homework. Running consumes 107 calories per mile if you run 10-minute miles. What is your average power output in watts during a 2-hour run? All right, 1 calorie equals 4,184 joules, and a joule per second is a watt. Okay, so we need that to be able to do this because it wants it measured in watts. So you can also think of that as joules per second if it helps you. Okay. Okay, so to get this, we need to first come up with how many miles we're going to run. Okay, so we're burning 107 calories per mile, and we need to get that into joules per second. So if we take this 2-hour run and we run 10-minute miles, we can come up with how many miles we're running with a simple conversion here. Okay, so 2 hours is 120 minutes. Okay, 60 minutes per hour, that's 120 minutes. And then if we're running 10-minute miles, if we divide that by 10 minutes per mile, we end up with 12 miles. Okay, so we burn 107 calories per mile. We ran 12 miles, so I'm going to take 107 and multiply that by 12. Alright, that's 1280. So that's 1,284 calories I burn in 2 hours. Okay, that's how long they ran. 2 hours is 12 miles. 107 calories per mile is times 12 is this is how many calories they burned in those 2 hours. Now, why is that important? Because we've got calories, which we can easily convert to joules now, and we've got hours, which we can convert to seconds. And then our units will be joules per second, which is a watt, and then we'll have our answer. Alright, so the first thing we need to do is convert calories to joules, or minutes, hours to seconds, but calories to joules has to be done, so let's go ahead and do that. So calories is in the numerator, so down here calories is going to be the denominator. Right? There is 484 joules, so I'm going to put a J up here, and then the 4184 goes up top for 1 calorie. Right now calories are gone. Okay, so I have joules per hour right now. I need joules per second. So I need to convert hours to minutes and then minutes to seconds. So I'm going to put 2 more little fraction bars on here. Hours is in the denominator, so I need to have it in the numerator here for it to offset. And I'll first convert to minutes, and then I'll convert minutes to seconds. Okay, so 1 hour is 60 minutes. 1 minute is 60 seconds. Hours cancel. Minutes cancel. And now you look, everything that canceled, the only units left are joules per second. So when we do all this multiplication, our answer will be in joules per second, which is a watt. Alright, so the 1284 times 4184 is this number down here, 5,372,256. And then we got 60 times 60 is 3,600 times 2 is 7,200. Again, the units left are joules per second. And then I'm going to divide this and then just convert joules per second to watts. So 746.15 roughly. And I'm going to convert that to watts. Alright, and then here are those questions in the homework. So 54.72, 43.94. Alright, and then 362.5, 655.95. Okay, those are the things that we got when we did those. And then number 9, there's the 746. Alright, 746.15, just rounded to the nearest whole. Is what it's asking you here. Okay, so there's some first couple examples. I'll give you a couple more in the next video.